Welcome to SureSolv. This is Atanu Chaudhary. In this 14th video in the series of algebra problem solving in a few steps, we'll be solving one complex problem with first a general technique and second a specific pattern-based technique. At the end, we'll solve a second problem using the pattern-based technique. Let's solve. The problem is, if x minus a square by b plus c plus x minus b square by c plus a plus x minus c square by a plus b equal to 4a plus b plus c, with a, b and c positive real variables, value of x is option A square plus b square plus c square, option B ab plus bc plus ca, option C a square plus b square plus c square minus ab minus bc minus ca, and option D a plus b plus c whole square. It takes long to state the problem itself. It's a complex problem and it involves as many as 15 elementary terms and 4 variables, out of which we have to solve the equation for x. We find no easy way to solve the problem at all, but we detect a specific pattern by which we are sure to solve the problem. Let's go into the specific pattern we see. First, we see that the 3 terms on the left hand side are perfectly balanced and symmetric between the 3 variables a, b and c. By this we mean that if we interchange any of the 2 variables between a, b and c, the expression on the left hand side will remain essentially unchanged. This is the first necessary condition for applying this technique. The second condition is, on the right hand side there will be an extra term. This we call a secondary term, while the terms on the left hand side we call as primary terms. The secondary term here is 4a plus b plus c. We take the decision then to apply secondary term value sharing method. In this method, we just share fully and equally the term value on the right hand side between the 3 terms on the left hand side. That's what we have to do. But can we share equally and fully? How to divide 4 between 3? That is the problem. So we apply a general technique for simplifying the complexity of an algebra problem. We substitute p, a dummy variable, for a plus b plus c. So the equation becomes x minus a square by p minus a plus x minus b square by p minus b plus x minus c square by p minus c equal to 4p. We have replaced b plus c by p minus a, c plus a by p minus b, and a plus b by p minus c. At the first step of sharing, we assign one number of minus p to each of the terms. Minus p, minus p, and minus p. So the 4 is erased, only one p remains. Now how to share this p now? Now is the time to expand p to its original form of a plus b plus c. These 3 terms a, b and c we will share equally between the 3 terms on the left hand side, which will satisfy the conditions of the method fully. Now the question is, which one of a, b and c to allot to which of the terms? By the nature of the terms, it is now quite easy to visualize that minus a is to be assigned to the first term. Assigning minus a to the first term, the shared value becomes minus p plus a. For the second term, the shared value becomes minus p plus b, and for the third term, minus p plus c. So the right hand side becomes 0. We remove a plus b plus c and replace it by 0. Now can you see the solution? When you combine x minus a square by p minus a with minus p plus a, the minus a square in the numerator gets eliminated, leaving just x minus p square. What happens with the second and third combinations? The numerator in these 2 cases also become x minus p square. So we can take out x minus p square as a factor. What happens with the second factor? we convert back P minus A to B plus C, P minus B to C plus A, and P minus C to A plus B. So the result becomes first factor x minus B square, and the second factor 1 by B plus C plus 1 by C plus A plus 1 by plus B equal to 0. As A, B and C are all positive real variables, the second factor cannot be 0. This cannot be 0. So x minus B square must be equal to 0, giving x equal to B square equal to A plus B plus C whole square. It's not difficult ultimately. Answer option D. How did we solve the problem? First, we identified a specific pattern and took the decision to apply secondary term value sharing method. Second, we simplified the complex expression by substituting P for A plus B plus C. And the third step, we have shared equally and fully the right hand side term for A plus B plus C between the three terms on the left hand side. That gave us the solution finally. This is a systematic and powerful method that you can apply to solve such complex problems. Now we'll solve a simpler problem using the same pattern-based method. The second problem states, if P minus A square divided by B square plus C square plus P minus B square divided by C square plus A square plus P minus C square divided by A square plus B square equal to 3, then the value of P is option A, minus A square minus B square minus C square, option B, A square minus B square minus C square, option C, A square minus B square plus C square, and option D, A square plus B square plus C square. As you see, the three terms on the left hand side are perfectly balanced between the three variables A, B and C. So the first condition is satisfied. On the right hand side of the equation also, we find an extra term of 3. As the value is exactly divisible by 3, we assign minus 1 to each of the three terms. The equation is changed to P minus A square by B square plus C square minus 1 plus P minus B square by C square plus A square minus 1 plus P minus C square by A square plus B square minus 1 equal to, this time it is 0, first time itself. Now it is very easy to see the solution at this point itself. All the three numerators become P minus A square plus B square plus C square, so that it can be taken out as a factor. The equation is changed then to P minus A square plus B square plus C square with the second factor as 1 by B square plus C square plus 1 by C square plus A square plus 1 by A square plus B square equal to 0. As the second factor consists of all the square terms, it cannot be 0. So the first factor must be 0. That means P equal to A square plus B square plus C square. Answer is option D. This problem is also solved by applying the secondary term value sharing technique, and the sharing is very easy in this problem, so that it could be solved very quickly in a few tenths of seconds. This concludes the session. Subscribe to our channel for more such videos. Thanks for watching.